This video is going to cover angles, adjacent, vertical, complementary, and supplementary, as well as finding angle measures and naming triangles. So let's go ahead and get started. Our first set of questions say name two pairs of adjacent angles. So here, remember, adjacent angles share a common vertex as well as a common side. So here we're going to make sure we name our angles with that angle symbol. And we're just going to pick one angle. I'm going to pick angle TQP. And then an adjacent angle, meaning an angle that shares that same vertex Q and a side. I'm going to go ahead and pick angle TQS. You could have also picked angle PQR. That works as well. But I just decided to pick those two. So it asks for two pairs. So that is one pair. So I'm going to go ahead and start with angle RQS. So this is my second pair, RQS. And then I'm also going to do angle SQT. Again, that one has another option. So these are not the only two pairs of adjacent angles. But make sure you're naming your angles with this angle symbol as well as keeping the vertex in the middle. So let's go ahead and keep going. It says name two pairs of adjacent angles again here. So this is a different picture. So I'm going to do angle TUV and angle VUW. Again, there's more options, but I just decided to choose those two. And then I'm going to go ahead over here and do angle XUY. Angle XUY. And then I'm going to pick angle YUZ. And that's another two pairs of adjacent angles. So those adjacent angles share a common vertex as well as a common side. Our next ones say to name two pairs of vertical angles. So this one's a little bit different. We're looking for vertical angles. And those are angles that are across from one another. And we know that vertical angles are always congruent, meaning they have the same angle measure. So that's going to come up later on in the video. But I'm going to go ahead and pick angle PQR. And the only option for a vertical angle is one diagonal from it, or across from it, excuse me, and that's angle TQS. I could have also named it SQT, as long as that Q is still in the middle of my angle name. And then I want two pairs, that's only one pair. So then my other pair is angle PQT, and that vertical angle pair is angle RQS. I always like to trace it on the picture just to make sure I'm naming the correct angles and in the correct order. Again, we want to name two pairs of vertical angles. Now this one's a little bit trickier because we have this ray right here. And remember, vertical angles are only formed by two lines that are intersecting. So really we're looking at this line here and this line here. So be careful when you're naming your vertical angles. So I'm going to do angle YUX, and that vertical angle is over here, which is angle VUW. And then I need another pair, and this is where it gets a little bit tricky. We have to ignore that ray, act like it doesn't exist, and I'm going to use this angle right here, and that's angle XUW, and that vertical angle is this one right up here, which is angle YUV. Here it says tell whether the angles are adjacent or vertical, and then we need to find the value of x. So there's two steps here. We're going to first decide if they're adjacent or vertical, and then find the value. So here, since they share this common vertex and a common side, we should know that these are adjacent. So we're going to write the word adjacent, and remember that is in our direction, so we shouldn't have to spell it incorrectly. And then to find the value of x, these two angles, these two adjacent angles actually equal 180 because that's a straight angle here. So I know that 34 plus x is going to equal 180. So I'm going to solve for x by getting x by itself. So when I subtract 34 from both sides, I'm left with just x on the left, and here x equals 146. So x is 146 degrees. Our next question, again, same directions. Are they adjacent or vertical? And then solve for the value of x. Here again, they share that same vertex and a common side, so these are adjacent as well. And here we're given that marking that these two angles together equal 90 degrees. So again, we have that 74 degrees plus x is equal to 90. I want to solve for x, so I'm going to subtract 74 from both sides. Make sure you're showing your steps here. I want to be able to see the setup of the equation as well as getting the variable by itself. So here when we get 90 minus 74, we get 16, so x is 16 degrees. Again, tell whether the angles are adjacent or vertical. Here, these are actually vertical. They're across from one another, so we're going to name these vertical. And then we know that with vertical angles, they are actually equal to one another. So I can put x plus 10 is equal to 59. Here, we solve for x just like we have been doing, and we get x to equal 49 degrees. Let's keep going. Our next one, again, same directions, except we're dealing with complementary or supplementary. So those are our only two options. They either equal 90 degrees or they equal 180 degrees. So here there's no 90 degree marking, so we know that together these are supplementary. Supplementary angles, and we know that the sum of these two angles equal 180. So 2x plus 5 plus 75 is equal to 180. So I'm going to combine some like terms here, and I'm left with 2x plus 80 equals 180. And then I'm going to start solving for my variable. So here this is a two-step equation now. Subtract 80 from both sides. You're left with 2x is equal to 100. So when we divide both sides by 2, we're left with x to equal 50. So we know that these are supplementary and that x equals 50. Our next question, same directions, complementary, which is 90, or supplementary, which is 180, and then find the value of x. We're given that marking, that 90 degree marking, the right angle, so we know that these are complementary. And then we can set the sum of these two together, so x plus 3x minus 6 is equal to 90. Again, I'm going to combine some like terms, so together I have 4x's minus 6 equals 90, and then solve this two-step equation, so add 6 to both sides, and we get 4x is equal to 96. From that point, we want to solve for x by dividing by 4, and we get x to equal 24. Our next questions are going to focus on triangles. We need to find the value of x and then classify the triangle. So one of our two rules of triangles is that the sum of all of the interior angles is equal to 180. So we add up all those three angles here, and that should equal 180. And we can use that in order to solve for our variable. So if we add 40 and 25 together, we get 65 plus our x degree angle and set that equal to 180. Then since we have this one-step equation, we're going to solve for our variable, isolate it here, and we subtract 65 from both sides. And we're left with x to equal 115 degrees. So that is half of it. Now we need to classify the triangle. And remember, triangles have two names. A classification based on their side lengths and a classification based on their degree measure. So I go ahead and start with the degree measures, and this one is an obtuse triangle since there's one obtuse angle, so I'm going to name this obtuse. And then with the lack of markings on our side lengths, we know that this is a scalene triangle. So this is an obtuse scalene. Our next one here, this marking here gives us a 90 degree angle. So again, we want to add these three up, 90 plus the two x's, because we have an x here and an x here, is equal to 180. When we subtract 90 from both sides, we're left with 2x is equal to 90. Divide that by 2, both sides, and we're left with x is equal to 45. So both of those x's equal 45 degrees. Since this is a right angle, we know this is a right triangle. And these two congruent markings make this isosceles. So this is a right isosceles triangle. Here again, we need to make sure we add up each angle measure and set that equal to 180. So I have 60 plus 60, which is 120, plus x minus 20 is equal to 180. I'm going to combine some like terms, that 120 minus 20. So I have 100 plus x is equal to 180. So I subtract 100 from both sides. And I'm left with x is equal to 80. Again, I'm going to do angle measures, so all three of my angles are actually acute, which makes this an acute triangle. And then these three congruent markings makes it equilateral. So this is an acute equilateral triangle. And that concludes our video. So go ahead and rewatch any of the sections you need to rewatch. Make sure you look over your notes, and so you know how to name triangles based on their angle measure and their side lengths, as well as the difference between complementary and supplementary, vertical and adjacent. Good luck studying!